Hello viewers, welcome back to our channel Career Prep. Today we'll learn all about squares and square roots, cubes and cube roots. This is a very important foundation topic which will help you while solving many problems in mathematics under various topics. So please understand this topic thoroughly. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. Let's understand the definition of squares. When a number is multiplied by itself, the product obtained is called the square of the number. For example, when 5 is multiplied by itself, the product obtained is the square of 5. That means 5 multiplied by 5 is equal to 25. Here 25 is the square of 5, or 5 squared is equal to 25. Similarly, minus 3 when multiplied by itself gives 9. This means minus 3 multiplied by minus 3 is 9. Or we can write this as minus 3 the whole square is equal to 9. Therefore, 9 is the square of minus 3. What is a perfect square? A perfect square or a square number is a natural number which is the square of another natural number. A perfect square is the square of another number. Consider the numbers 132 and 225. These can be written as a product of their prime factors. 132 can be written as 2 multiplied by 2 multiplied by 3 multiplied by 11. 225 can be written as 3 multiplied by 3 multiplied by 5 multiplied by 5. When you look at the number 132, you can see that it does not have pairs of identical factors. Although 2 is a pair of identical factors, you can see that 3 and 11 do not have identical factors. So 132 is not a perfect square. However, the number 225 has pairs of identical factors. 3 multiplied by 3 is one pair of identical factors. 5 multiplied by 5 is another pair of identical factors. So 225 can also be written as 3 squared multiplied by 5 squared, or 3 multiplied by 5 the whole squared. This is nothing but 15 squared. So 225 is equal to 15 squared. So 225 is a perfect square. It is the square of 15. Memorize the squares of at least the first 20 natural numbers. This will help you in solving problems quickly and correctly. Let us look at some of the squares of numbers. 1 squared is equal to 9. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225, 16 squared is 256, 17 squared is 289, 18 squared is 324, 19 squared is 361, and 20 squared is 400. Memorize the squares of these numbers. Let's learn about some of the properties of squares. Square of 0 is 0. This means 0 squared is equal to 0. Square of 1 is equal to 1. This means 1 squared is equal to 1. Square of positive numbers is positive in nature. For example, plus 2 multiplied by plus 2 will give you plus 4. So square of positive numbers is positive. Square of negative numbers is also positive in nature. For example, minus 3 multiplied by minus 3 will give you plus 9. So square of negative number is also positive in nature. Square of root of a number is equal to the value under the root. For example, square of 5 square of root 5 is 5. That is, root 5 the whole square is 5. The number under the root sign is 5. So root 5 the whole square is equal to 5. Square of root of a number is equal to the value under the root. Root of Another example will be root of 6 the whole squared will give you 6 as the answer because 6 is under the root. Here root of 5 the whole squared is 5 because the number 5 is under the root sign. The square of even numbers is always even. For example, 6 squared is equal to 36. 6 is an even number. So 6 squared, which is 36, is also an even number. 36 is also an even number. The unit place of square of any even number will have an even number only. For example, 8 squared is equal to 64. 8 is an even number. 64 is also an even number. 8 squared is equal to 64. The unit place of 64 is 4 and 4 is an even number. So the unit place of square of any even number will have an even number only. If a number has 1 or 9 in the units place, then its square also ends in 1. For example, 11 squared is equal to 121. Now 11 has 1 in its units place. So its square 121 also ends in 1. 11 squared is equal to 121. Consider another example, 19 squared. 19 squared is equal to 361. 19 has 9 in the units place. So its square 361 ends in 1. So if a number has 1 or 9 in the units place, its square will end in 1. If a number has 4 or 6 in the units place, then its square ends in 6. For example, 14 squared is equal to 196. 16 squared is equal to 256. 14 has 4 in the units place. So 14 squared is equal to 196 and 196 ends in 6. 16 has 6 in the units place. So 16 squared is equal to 256 and 256 has 6 in the end. So if a number has 4 or 6 in the units place, then its square will end in 6. Next property. The difference of the squares of two consecutive numbers is equal to the sum of the numbers. For example, 3 squared minus 2 squared is equal to 5. 5 is nothing but 3 plus 2. Now 2 and 3 are consecutive numbers. The difference of the squares of two consecutive numbers means 3 squared minus 2 squared. The answer is 9 minus 4, which is 5. 5 is nothing but the sum of the numbers 3 and 2. 5 is equal to 3 plus 2. Now let's learn how to identify a perfect square number. A number whose exact square root, which is a whole number, can be obtained is called a perfect square. A perfect square is a number whose exact square root can be obtained, and the square root will be a whole number. A number ending with 2, 3, 7 or 8 cannot be a perfect square. So any number ending with 2, 3, 7 or 8 cannot be a perfect square. For example, 12 is not a perfect square, 13 is not a perfect square, 27 is not a perfect square, 48 is not a perfect square. Next, a number ending with odd number of zeros cannot be a perfect square. For example, 9,000. 9,000 has 3 zeros. That is an odd number of zeros. So 9,000 is not a perfect square. However, 90,000 will be a perfect square because it will have an even number of zeros, that is 4 zeros. Or 900 is also a perfect square because it has 2 zeros, that is even number of zeros. So 900 also will be a perfect square, but 9000 is not a perfect square because it has an odd number of zeros. Similarly, 49,000 is not a perfect square because it has an odd number of zeros, that is 3 zeros. 49,000 is not a perfect square. Now let us learn how to find how many numbers are there between two square numbers. Suppose there are two square numbers n squared and n plus 1 the whole squared. Then total numbers between these two squares is given by 2n. This means supposing there are two numbers n squared and n plus 1 the whole squared. You have to find out how many numbers are there between n squared and n plus 1 the whole squared. This can be found out by using the formula 2n. Let's understand this with an example. Let's say 4 squared and 5 squared are the two squares. Remember that n and n plus 1 are consecutive numbers. So you have to take 4 and 5 because 4 and 5 are consecutive numbers. So now 4 squared and 5 squared are the two squares. So 4 squared is 16 and 5 squared is 25. We need to find out how many numbers are present between 16 and 25. Here n is equal to 4 because n squared is 4 squared, n plus 1 squared is 5 squared. If n is 4, then n plus 1 is 5. So here n is equal to 5. Therefore total numbers between 16 and 25 is equal to 2n. That means 2 multiplied by 4, which is 8. So there are 8 numbers between 16 and 25. Let's see whether this is correct. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. As you can see, there are 8 numbers between 16 and 25. So, when you have to find out how many numbers are there between n squared and n plus 1 the whole squared, you have to use 2n. So, n squared and n plus 1 the whole squared, you have to use, if you use 2n, you will find how many numbers are present between n squared and n plus 1 the whole squared. Now let us learn what are square roots. The square root of a given number is the value which when multiplied by itself gives the original number. For example, square root of 25 is 5. 5 multiplied by itself gives the original number 25. So, the square root of a given number is the value which when multiplied by itself gives the original number. Supposing square root of n is a. This means that a multiplied by a is equal to n. The symbol for square root is called the radical. Now you have to remember that the square root of 25 can also be minus 5 because minus 5 multiplied by minus 5 is also 25. So the square root of 25 could be either minus 5 or plus 5. But when we use the radical symbol, we only consider the positive number. You can find the square root of a negative number also. For example, the square root of minus 25 can be found out. But the square root of a negative number is an imaginary number. And this topic will be dealt with in another video. Here, in this video, we'll deal only with positive numbers. Let's learn how to find square roots of perfect squares. Square root of a perfect square can be found out either by prime factorization method or long division method. Now let's learn how to find square root by prime factorization method. This is a very important method to find square roots of numbers. To find the square root of a perfect square through prime factorization method, you have to follow these steps. First, divide the given number into its prime factors. Then group the factors obtained into groups containing two same factors. Take one factor from each group. Find the product of the factors obtained by taking one factor from each group. That product is the square root of the number. Let's understand this with an example. Let us find the square root of 196 by prime factorization method. First, divide 196 into its prime factors. First, divide 196 by 2. You will get 98 as the quotient. Divide 98 again by 2, you will get 49. Divide 49 by 7, you will get 7. Divide 7 by 7, you will get 1. So, 196 can be written as a product of its factors 2, 2, 7 and 7. So 196 is equal to 2 multiplied by 2 multiplied by 7 multiplied by 7. Now you have to group these factors into groups containing two same factors. So 2 and 2 will form one group, 7 and 7 will form another group. So 2 multiplied by 2 is one group and 7 multiplied by 7 is another group. Now take one factor from each group. From this group you take 2 and from this group you take the number 7. So you will get 2 multiplied by 7, which is nothing but 14. So square root of 196 is 14. Hope you have understood this method. First, you have to divide the given number into its prime factors. So 196 is divided continuously till you get 1 as the last quotient. So 190, the prime factors of 196 are 2, 2, 7 and 7. So 196 can be written as 2 multiplied by 2 multiplied by 7 multiplied by 7. Now you group these factors obtained into groups containing two same factors. So 2 into 2 is one group and 7 into 7 is another group. Take one factor from each group. So you take 2 from this group and 7 from this group. You will get 2 multiplied by 7, which is nothing but 14. So square root of 196 is equal to 14. Square root of 196 is 14. Now let's learn how to find square root by long division method with an example. Find the square root of 53824 by long division method. To find the square root of 53824, first you have to pair the digits from right side to the left side. So you can pair 2 and 4 into one group, 3 and 8 into another group, and since there is no other digit along with 5, you can take 5 as it is. So you have 24 as one group, 38 as another group, and 5 you will consider as it is. Now start the long division method. You have to find two digits when multiplied by each other will give you number 5 or a number that is less than 5. So 2 multiplied by 2 will give you 4. So write 2 in the divisor place and 2 in the quotient place. 2 multiplied by 2 is 4. 5 minus 4 is 1. Next bring down the next group, that is 38. When you bring down 38, the new number will be 138. Since you had written 2 in the quotient place, you have to add 2 to the divisor. 2 plus 2 is 4. Now you have to write a number next to 4 such that the number written next to 4 is written in the quotient place also. And when you multiply this divisor with the number written in the quotient place, you have to get a number that is either 138 or less than 138. So if you write 3 next to 4, you will get 43. Write 3 in the quotient place also. So 43 multiplied by 3 is 129. 138 minus 129 is 9. Bring down the next group, that is 24. When you bring down 24, you will get the number 924. Since you have written 3 in the quotient place, now add 3 to the divisor 43. 43 plus 3 is 46. Now if you write 2 next to 46, you have to write 2 in the quotient place also. 462 multiplied by 2 is nothing but 924. 924 minus 924 is 0. So finally you got the answer as 232. So square root of 53824 is 232. Hope you have understood the concept of finding square root by long division method. Let's have a quick recap. To find a square root of the number 53824 by long division method, first pair the digits in the given number from right side to left side. So 24 is paired as one group, 38 is paired as another group, and since there is no other digit that can be paired with 5, we'll consider 5 as it is. Now write 2 in the divisor place and 2 in the quotient place. So 2 multiplied by 2 is 4. 5 minus 4 is 1. Bring down the next group, that is 38. Now the number will become 138. Since you had written 2 in the quotient place, add 2 to the divisor. So 2 plus 2 is 4. Now write 3 next to 4 and 3 in the quotient place also. So 43 multiplied by 3 is 129. 138 minus 129 is 9. Bring down the next group, that is 24. When you bring down 24, you get the number 924. Since you had written 3 in the quotient place, add 3 to the divisor 43. 43 plus 3 is 46. Now write 2 next to 46 and 2 in the quotient place also. So 462 multiplied by 2 is 924. 924 minus 924 is 0. So you got the answer as 232. The square root of 53824 is 232. Hope you have understood this concept correctly. Now let's learn how to find the square root of a fraction. To find the square root of a fraction, you have to understand one important concept. That is, for any positive number x and y, the square root of the whole fraction x upon y is equal to square root of x upon square root of y. So square root of x upon y is equal to square root of x upon square root of y. This is a very important concept. Now, the square root of different types of fractions can be found out using different types of methods. Let's learn some of these methods. The square root of some fractions can be determined by finding the square root of the numerator and denominator separately. This means for some fractions, you can find the square root by finding the square root of the numerators and the square root of the denominator separately. Let's understand this with an example. This, how to find the square root of 36 upon 25. The square root of 36 upon 25 is nothing but the square root of 36 upon square root of 25. Now the square root of 36 is 6. The square root of 25 is 5. So the square root of 36 upon 25 is nothing but 6 upon 5. What you have done here is you have found the square root of the numerator and the square root of the denominator separately. So square root of 36 upon 25 is equal to square root of 36 upon square root of 25. Square root of 36 is 6 and square root of 25 is 5. So square root of 36 upon 25 is nothing but 6 upon 5. You have found out the square root of the numerator and the denominator separately here. Next method. Some fractions can be reduced to fractions with perfect squares as the numerator and denominator. Then the square root of the simplified fraction can be determined. Let's understand this with an example. Find the square root of 32 upon 50. Here you cannot find out the square root of the numerator and the denominator because they are not perfect squares. But you can reduce 32 and 50 to 16 and 25. When you divide 32 by 2, you get 16. When you divide 50 by 2, you get 25. So 16 upon 25 is the reduced form of 32 upon 50. So square root of 32 upon 50 is nothing but square root of 16 upon 25. Now you can find the square root of 16 by 25 by finding the square root of the numerator and square root of the denominator separately. So square root of 16 upon 25 is equal to square root of 16 upon square root of 25. Square root of 16 is nothing but 4 and square root of 25 is nothing but 5. So square root of 16 upon 25 is equal to 4 upon 5. Here, hope you have understood this, because in this example 32 and 50 are not perfect squares. So you have reduced them by dividing the numerator and the denominator with 2 to get 16 upon 25. So now what you have to do is to find the square root of 16 upon 25. Square root of 16 upon 25 is equal to square root upon 16 and square root of 25. Now 16 and 25 are perfect squares. So square root of 16 is 4 and square root of 25 is 5. So the square root of 32 upon 50 is 4 upon 5. Now let's learn how to find the square root of a mixed fraction. For a mixed fraction, first you have to change the mixed fraction to an improper fraction before finding the square root. Let's look at this example. This square root of 156 by 169. The number 156 by 169 is a mixed fraction. So this number has to be changed to an improper fraction before finding the square root. To convert the mixed fraction to improper fraction, you multiply 169 with 1 and then add 56. So 169 multiplied by 1 is 169 plus 56 is 225. So now we have an improper fraction 225 upon 169. Now find the square root of 225 upon 169. The square root of 225 upon 169 is nothing but square root of 225 upon square root of 169. Here you have to find the square root of the numerator and denominator separately. Square root of 225 is 15. Square root of 169 is 13. So square root of 225 upon 169 is nothing but 15 upon 13. 15 upon 13 can be written as the mixed fraction 1, 2 by 13. So finally you have found out the square root of 156 upon 169 is nothing but 1, 2 by 13. For a mixed fraction, before finding the square root, convert the mixed fraction into an improper fraction. Then find the square root of the improper fraction. The answer you get is the square root of the mixed fraction. Hope you have understood this. Now let's learn how to find the square root of a rational decimal fraction. A decimal fraction is nothing but a decimal number. To find the square root of a rational decimal fraction, you have to follow these steps. A decimal number has two parts, the integer part and the decimal part. So first pair the integer part. Next, you have to start pairing the decimal part. So to do that, first you have to check the number of digits after the decimal point. If the number of digits after the decimal point is even, then there is no problem. You can just pair two digits into a group. But if the number of digits after the decimal point is odd, then you have to add a zero on the extreme right of the decimal part to make even number of decimal places. That is, if there are odd number of digits after the decimal point, then add a zero at the extreme end, so that now you will get an even number of digits after the decimal point. Once you get an even number of digits after the decimal point, you can pair two digits into one group easily. Now pair the decimal part accordingly. Next, you have to find the square root by long division method. While doing this, you have to put the decimal point in the square root as soon as the integer part is exhausted. Let's understand this with an example. Evaluate the square root of 42.25. Here 42.25 is a decimal number. 42 is the integer part and 25 is the decimal part. So first group the integer part. So 42 is one group. Next, look at how many digits are there after the decimal point. Here there are two digits after the decimal point. So there are an even number of digits after the decimal point. So there's no problem. You can just group the two numbers into one group. So 42 is one group and 25 is another group. Now you have to find the square root of 42.25 using the long division method. Write 6 in the divisor place and 6 in the quotient place. 6 multiplied by 6 is 36. 42 minus 36 is 6. Now the integer part is done with. So, and the decimal point starts. So write a decimal point in the quotient place also. Next, bring down the uh, pair of numbers after the decimal point, that is 25. When you bring down 25, the new number will be 625. Since you had written 6 in the quotient place, now add 6 to the divisor. 6 plus 6 is 12. Now, if you write 5 next to 12 and 5 in the quotient place, you will get 125 multiplied by 5, which is 625. So 625 minus 625 is 0. If you write 6 here next to 12 and 6 in the quotient place, you will get 126 into 6, which will be more than 625. So you have to write 5 next to 12 and 5 in the quotient place. So 125 multiplied by 5 will be 625. And 625 minus 625 is 0. So finally you got the answer as 6.5. So square root of 42.25 is 6.5. Now let's move on to cubes and cube roots. What are cubes? The cube of a number is the number raised to the power 3. That is, the number is multiplied by itself 3 times. Square of a number, the number is multiplied by itself 2 times. Cube of a number, the number is multiplied by itself 3 times. So 5 cubed means 5 is multiplied by itself 3 times. That is 5 multiplied by 5 multiplied by 5, which is nothing but 125. So the cube of 5 is nothing but 125. The cube root of a given number is equal to the number which when multiplied thrice gives the given number. This means the cube root of any number is a number which when multiplied by itself 3 times will give the given number. Let's understand that with an example. The cube root of 125 is 5. So 5 multiplied 3 times by itself will give you 125. 5 multiplied by 5 multiplied by 5 is equal to 125. So the cube root of 125 is 5. To solve problems on cubes and cube roots quickly, memorize the cubes of at least the first 10 natural numbers. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729 and 10 cubed is 1000. Memorize the cubes of at least these first 10 natural numbers. Now let's learn how to find cube root by prime factorization method. To find the cube root of a perfect cube through the prime factorization method, you have to follow these steps. First, you have to divide the given number into its prime factors. Then, group the factors obtained into groups containing 3 same factors. Next, take one factor from each group. Find the product of the factors obtained by taking one factor from each group. That product is the cube root of the given number. Let's understand this with an example. Find the cube root of 5832 by prime factorization method. So first, divide the given number 5832 into its prime factors. So divide 5832 by 2 first. You will get 2916. Divide again by 2. You get 1458. Divide again by 2. You will get 729. Divide by 3. You will get 243. Divide 243 by 3, you will get 81. Divide 81 by 3, you will get 27. Divide 27 by 3, you will get 9. Divide 9 by 3, you will get 3. And divide 3 by 3, you will get 1. So 5832 is the product of all these prime factors. So 5832 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 3 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 multiplied by 3. Now you have to group the factors. You have to group these factors into groups containing 3 similar factors. So here you can group 2, 2 and 2 into one group. So 2 multiplied by 2 multiplied by 2 is one group. Then 3 multiplied by 3 multiplied by 3 is another group. Finally 3 multiplied by 3 multiplied by 3 is another group. Now you have to take one factor from each group. So 2, you have to take 2 from here, 3 from here and the number 3 from here. So you will get 2 multiplied by 3 multiplied by 3, which is nothing but 18. So cube root of 5832 is 18. Viewers, Please go through this video till you are perfect with the concept. Memorize the squares and cubes of numbers. Also understand perfectly the methods of finding the square root and cube root of numbers. Watch our next video to learn shortcut methods to find squares of numbers. If you have liked this video, please like, subscribe and share this video. Thank you.